So my name is Sheng. I'm from Rancher Labs. I'm the co-author and the current maintainer of Longhorn. So today, of course, we know the topic. We are talking about Longhorn, which is our open source cloud-native distributed block storage built on and for Kubernetes. So Longhorn is the newest member of CNCF. It was accepted as a CNCF sandbox project about a month ago, and we're really honored to have CNCF supporting Longhorn. So Longhorn, as I said, is a distributed block storage for Kubernetes, and you can find more information at longhorn.io. One thing about Longhorn we want to emphasize is we want it to be easy to use, easy to be operated, and have a great user experience. Compared to other storage softwares, we feel like many of them are really unnecessarily complex, and also because of their complex architectures, there's many technical difficulties and difficulty in operations. So compare Longhorn to the other legacy storage softwares. We want to leverage the modern high-speed, high-capacity SSD and NVMe and proven Linux storage features, and not really invent everything from the scratch. And there's one point we know that as a legacy storage software, they tend to have very complex logic to create a very high availability storage controller to handle very high IOPS and throughput across the cluster. And that could be a bottleneck, and if you have too many nodes and too many traffic in your cluster. In Longhorn, we follow the microservice pattern, and each volume is in fact a set of independent microservices and orchestrated by the Kubernetes. In the end, with the help of the Kubernetes and other existing mature technology, we're able to implement Longhorn in only about 40,000 lines of the Golang code divided into the clean modules, compared to the hundreds of thousands lines of code and probably writing in the C++ from the other storage softwares. So let's talk a little bit about the history of Longhorn. In fact, we started the project very early, and if you remember, the Rancher Lab started at September 2014, and which is also the first start time for Longhorn. The first iteration, we don't really think out of the box. We think, okay, storage have to be complex, you have to be very high performance, and you probably need to be writing in C++. So that's basically what we go with the first iteration. But since the second iteration, we realized that we can do things in a much simpler way, but still offer the same stability and still offer a very powerful experience. So on the second iteration, we decided to write Longhorn in Go, and also in order to track more traction on the community, we decided just to build it from scratch and make it open source with Apache 2 license. But at the time, Longhorn was building with the Docker in mind. At the time, Kubernetes is basically competing with Mesosphere, Docker Swarm, and Rancher Cattle. So, but 2 years later, around the end of 2017 and 2018, we saw that Kubernetes is basically taking off. And at the September 2017, Rancher Labs has published Rancher 2.0, which is the totally different product from the Rancher 1.6, which is used in the Rancher Cattle. And the Rancher 2.0 is a multiple Kubernetes cluster management platform for, of course, Kubernetes. And since Rancher pivoted and the Rancher Labs other projects, we also see that it's really necessary for us to change. So on the third iteration, we are still writing in Go, but we start in building Longhorn, rebuild the Longhorn control plane on over the Kubernetes. So since then, we have 12 formal releases. We have about 900 stars in GitHub now. On the right side, you can see that the trend of our GitHub stars is starting out pretty slow at the bottom, and just before we joined the CNCF, the traction getting up, and after we joined CNCF, the things really a little bit looks like it's taking off. I hope that's the trend to keep. So last week, we have announced the latest Longhorn release, which is 0.7.0, and also is the first long beta release for Longhorn. So in the latest release, 0.7.0, we're still offering the enterprise-grade distributed block storage software for Kubernetes, and we support volume snapshot and a backup and a restore. The difference between the snapshot and the backup is that snapshot you take will be kept inside your Kubernetes cluster, but you can back up your snapshot into the third party like the S3 or NFS server. So even your whole cluster is somehow suffers some disasters, you still have your data kept safe. So we support storage tag feature for node and disk selection. So you can select which disk, which, for example, some with SSD and some are spinning disk. If you want more I/O ops, you can put your Longhorn volume based on the SSD disk, or you can select, say, using spinning disk for the slower workload. We support cross-cluster disaster recovery volume with defined RTO and RPO, and I'm going to demonstrate that later. And we also support live upgrade of Longhorn software without impacting the running volumes. Many users told me the first thing we caught them eyes on Longhorn is because that's the intuitive UI. So by default, Longhorn installed with UI, and it's open source. It's of course open source, and we're finding that UI really helps users to understand what is going on in their system. And many users also give us feedbacks on how to improve the usability on the UI. Longhorn, as any other cloud-native software, we support one-click installation. You can install Longhorn, use one line of YAML or Helm install, or you can just select, if you are using Rancher, you can select the Longhorn in the Rancher app catalog, and then just install from there. That's probably take you about 3 clicks. And more features are coming. So now let's do a live demo of the latest Longhorn beta release. So, all right, so is that big enough? OK. So here, you see that it's the Rancher 2.3.2, and I have 3 Kubernetes clusters spin up here. And I'm going to use 2 of them, demo and demo 2, for today's demo. So for now, I'm going to select storage project, which is basically just Rancher concept saying that it's the namespace group. And I'm going to select apps and launch. And I will find Longhorn here. And in the backend, it's essentially a Helm chart, and I make sure that version is 0.7.0. And I don't need to set up anything. I just click launch. So now we can go back to take a look at the workload, and you can see that the Longhorn Manager UI and driver deployer, they're in the update in the deploying process. And one by one, they're starting. And you can see that there's another demo set called engine image, and some instance manager are starting up. Those are all Longhorn's components. And finally, the driver deployer will see that Longhorn Manager is available and start deploying the CSI driver. So Longhorn currently, in the latest beta release, we support CSI 1.1. And we do require Kubernetes 1.14 plus to install Longhorn at this moment. So now everything seems deploying fine. Let's go back to the apps and click this link. We are going to take a look at the Longhorn UI. So the first page you see that is a dashboard, and the left side is the volume count, which we don't have any right now. The middle side is you can see the real-time storage usage in your system, across your whole cluster. And the right side is to say that what's the node status in this cluster. So in the node page, this is the place you can customize how do you like Longhorn to use your storage, or do you want Longhorn to only use part of storage in the one disk, or in the one node, or you can add more disk into here. So for example, you can see that because I did no configuration, by default, Longhorn is using the var lib rancher Longhorn directory on on your host, on your node, to provide the storage for Longhorn. Of course, this is changeable, and we are also in the progress of changing this directory to the while-lib Longhorn, because Longhorn now is part of CNCF and no longer Rancher. So click Edit Node and Disk. Now you can choose that if you want any volume to be scheduling to be used, the storage on this node, and if you want to choose the storage to be used on this disk, and also you can add a new disk here. To add a new disk, you only need to format your block device attached to the node and mount it somewhere in your root FS and put the mount path here. And then Longhorn can automatically pick it up and use it for the volumes. So nothing is right now in the volume page because we haven't put anything yet. And the backup is the one I mentioned before. Say you can take a snapshot, and you can back up your snapshot and your volume data into our backup store, which is backing up by the S3 ONFS. So I'm going to set up that right now. So in the settings, I just choose this backup target. And this is the credential was stored in this Kubernetes secret. It's named S3-secret. And once you click Save, Longhorn should be to recognize the contents in that secret and connect to the S3 and read the list of the existing backup from that backup store. So, OK, so now we got the list of the backup here. And let's start using Longhorn. So for the demo purpose, I'm going to use a WordPress app. I still launch from the Ranch app catalog. I go find WordPress. And here, I need to set up WordPress password. And click Enable Persistent Volume for the WordPress. And choose Longhorn as a storage class. And here, for the MariaDB, I need to set the password as well. And choose the persistent volume to be enabled. And of course, Longhorn. And launch. So now, Kubernetes should be talking using CSI plugin to the Longhorn to start those two volumes. Let's see, OK. So those two volumes wasn't there the moment before, and now they are starting and just created and in the attaching and attached state. Now Longhorn is saying, OK, the two newly created volume, it looks very healthy, so they changed the state to the healthy. So in this page, you can see the information, the major information you need for this volume, like what's the volume's name, which is in Kubernetes cases, if you provisioning volume using storage class, you normally will just see that it's a PVC plus some UUID. It doesn't really make much sense for you to associate that with the workload. But in fact, if you look at it here, we can detect the status of the Kubernetes, and we can get the information from that. We know that what's the PV name, and what's the PVC name, and what namespace this volume being used to, and which workload this volume has been used to. So this is MariaDB, and this MariaDB is running a stateful set, and the port name is WordPress.mariadb.0. So let's take a look at the details in the volume. Once you create a volume on the left side, you can see that the front end, in fact, is a block device. So in order to create this volume for the party to use, Longhorn has created this block device on the Longhorn Demo 1 node. And what's the size of this, and what's the actual size means that how many storage Longhorn really use on your disk for this volume. And other informations down below. On the right side, you can see that we have 3 healthy replicas running to support this volume. And each of them on the different node, Demo 3, Demo 1, and Demo 2. And also, in fact, you can see that this tooltip gives you the exact location on that node that stored the Longhorn data. So what if, just if, anything else goes wrong and you have a hard drive and you only have this directory available in that hard drive, you can still recover from the disaster. Only one replica is enough. So here, you can create snapshot. And as I mentioned, this is created inside the cluster. But if you want to have a backup, like say just take this volume outside the cluster and make sure that it's safe there, and you can create backups. For the backups, you can add more label to it. I'll just leave it empty for now. And the backup is in creating. I can leave it there and talk about it later. So we also provide a feature to create a recurring snapshot and backups. So you can just say, I want to create a backup, like in the middle light of every day, but for the demo verse, I'm just going to create backup every minute. And I will just return last 5 of them. Yeah, that's it. So because we cite the recurring backup, so this icon lists up, let you know that, OK, there's already backup scheduled for this one. And you won't lose data if you lost the cluster. And we can do the same for this volume as well. I think this is supporting the WordPress itself. Just set it every minute. Of course, this is not practical in the production. Don't try it yourself. Yeah, of course, you can try it if it's just for testing or for fun. So the backup was set. And let's take a look at if WordPress was really up. So because I started from the app, so I can just direct click this link, and it will bring me to the WordPress page. Yeah, it looks a little bit too simple, but I was told this is 2019 style. If I go to the user here and log in, if I don't get my password wrong, I should be there. Yes, that's right. So I can create a new post, and everything will be recorded by Longhorn. And let's say, for example, I create a new post that's Longhorn KubeCon and a demo. Publish. And view the post. Now the post is showing up, and make sure it works. Yes? Right. So, but how do you know that this data has been stored in Longhorn? In fact, another question can be, OK, so this is the one cluster. What if I lost this cluster, but I do want to have a highly available service? So we do offer the disaster recovery feature, which means that I can have a backup copy of the volume inside another cluster and waiting to be activated. So in order to do that, I already have this demo2 cluster set up, and also in the storage project, I have the Longhorn already installed here. And this is in the other cluster. So here, if I click here, because it's Longhorn installed in another cluster, there's nothing here. There's no volumes. But the backup store has already set up beforehand. So we should be able to see the list of just the backup we just created there. So you can see the latest two backup volume, they create just 2 and 3 minutes ago. That means that they are just created in this demo from the previous cluster. So in order to use the DR, OK, there's one thing I want to show you, that the backup not only contains the data, but also contains the metadata of the application using the volume at the time of the backup. So for example, this one, I can see the label here. And this volume is used by the WordPress. And you can see the original WordPress information here. And this helps us to decide that what this volume is really for. So because this is WordPress, I'm going to create disaster recovery volume for the WordPress. So the disaster recovery volume in Longhorn is just a volume that stay active, but what I only do is just incrementally restore from what they see from the backup store. So this one is the WordPress. Another one, it should be of course, MariaDB. And I'm going to create disaster recovery volume of that as well. So here, just verify that this is MariaDB. And let's create the DR volume for MariaDB. All right, so those two volumes are up and running and actively restoring from what they're seeing in the backup store. So how can I prove that? I just go back to this WordPress, and I will go in, because this volume was created before. So now I'm going to just change this WordPress, and I just add something more to it. So this post was created after I created the SDR volume. It should take about 1.5 minutes for this content to be replicated into the backup cluster. OK, so we're just waiting right now. Yeah, if anyone has some questions, I can answer a few of them now. And also, you can see that the last backup was created about a minute ago, and basically just now I'm monitoring this, and when this number changed to a few seconds ago, means a new backup was created. Yes? When you're storing your replicas, are you storing the complete data set of each replica, or are you doing any breaking where you're splitting out the data across the web? So the replica data are exactly the same, and the return to the replica is synchronized. So as long as you have one replica, that should be enough. And the replica itself is crash consistent. Yeah. Yeah, so in fact, because the synchronization is the replication is synchronized, it's really hard to, because network latency is really hard to do the cross-region replication. So this is why we have this. We are using backup store as a median to work to deal with this problem. And also because the Longhorn is the block device, it read once. You cannot able to write on a different side. So I think this current approach is more simpler and easier to deal with. All right, so I guess in the meantime, the backup should be already done. So now let's activate those DR volumes. OK, let's just close those two in the previous cluster for now. And assuming that, well, somehow you lost the cluster. So when you activate DR volume, they're going to check S3 for if there are any latest data I haven't restored. So it will take a little bit longer than normal. All right, so my SQL is up. But how can I use this DR volume in the application about to spin up? So you can create PV and PVC directly using the original data from your backup store, just from the Rancher UI. And now I just create the PV and the PVC and bound that PVC and PV to those two Longhorn volumes. So in the demo 2 environment, I'm going to spin up the WordPress and see if any change I made in the demo environment has been applied here. I need to put the same password. And of course, still enable the persistent volume. And now I can choose which persistent volume client I want to use it because I already created the volume beforehand. Of course, I want to choose WordPress. And the storage class, I think is probably not necessary, but just in case. Put the same password. Enable persistent volume. And you'll notice that MariaDB doesn't really give you an option to choose which volume you want to, which PVC you want to associate with that, because MariaDB is a stateful set, and as long as the stateful set name and is determined and the volume name is determined, the name of that PVC is automatically determined, like say the port name dash volume name dash 0, port name dash volume name dash 1. So there's no way I can choose that. But because we have information from our backup store to keep that metadata, everything should be working fine because we have the same name of the PVC. Let me double check. Yes. Click launch. If everything works fine, you should be able to see that both volume are start attaching. OK. And because they're calling the Kubernetes CSI plugin, it's calling Longhorn to provide those two volumes to the newly created WordPress application. And the WordPress is starting right now. OK, it probably takes about 1 minute for it to fully start it. All right, so I can answer a few questions now. Yes? OK, so the question is, how do Longhorn make sure that the pod always starts with the replica on the same node, right? So in fact, for the Longhorn, we don't have locality, so all the replicas are treated the same. And besides the replica, we have an engine which is always going to be located at the same node as the pod, which is also the consumer. So that in that way, we make sure that if you even have that pod is down and you want to spin out another pod, the engine can be moved from this down node to another pod and make sure you still have your service. OK, I think WordPress is up. Yeah. So just to make sure, this one is on the demo too. It's a totally different cluster and the newly spin up the WordPress. And now we see the content we shipped from demo 1 and the disaster recovery feature. OK, so this concludes my demo. Let's go back to the slide. So after demo, you're probably wondering how Longhorn works. So for Longhorn, we have two layers. One is what we call the data plane. Another one is what we call the control plane. In Longhorn's world, those are Longhorn engines and Longhorn managers. How Longhorn engine works is the foundation of the Longhorn itself. In this case, we have two nodes here, for example, and the Kubernetes create pod asking for volume. And the Longhorn are going to place two replicas on two different nodes, preferably, and on the probably different disks. And then Longhorn will create an engine connected to these two replicas, and the engine will expose a block device on the same node that pod is running. And the Kubernetes API, in fact, the Longhorn CSI driver will take the block device, format it, and mount it on the host, and Kubernetes we're going to bind mount it inside the pod. So that is how pod get to the access to the Longhorn volume. So in fact, it's very easy if you have even more pods. You just create more engines and replicas and connect them to make sure that try best to have replicas reside in a different node, and then connect to them and provide the volume. This approach has two advantages over the traditional way. The first one is because engine itself is like just a simple RAID1 controller. It's really easy to program, and also it's always reside in the same node as the pod running. So we don't really need to have a HA controller and make a lot of logic complex in order to do that. So another thing is you can see that the data path of each volume, in fact, is not really interaction with everybody else. So the data path of the pod 1 using the volume 1 is different from the volume 2 from the volume 3. So even if something wrong happens on, say, replica 1 or engine 1, it's not going to affect anybody else. All other volumes still function fine. So this isolation of the data path also ensured high availability of the Longhorn. But the question is, traditionally, we don't really have so many microservices there in order to create this volume. But how we do that? Because we have the help with Kubernetes. All these microservices, with the help of Kubernetes, we can precisely locate them to where they belong and where we think this best will fit them. As I said, another part of Longhorn is the Longhorn Manager and the Longhorn control plane. So in this case, we have a Kubernetes cluster, and they want to create a volume. And the Kubernetes cluster internally using the CSI interface to talk to the Longhorn CSI plugin. And the Longhorn CSI plugin going to talk with the Longhorn Manager using the Longhorn API. So Longhorn Manager orchestrates all the volumes and follows the Kubernetes controller pattern, or somebody called it operator pattern. In this case, Longhorn Manager, we're going to create a new volume CRD object inside the Kubernetes API server. And then another bunch of controllers inside the Longhorn Manager are monitoring the API server's response and see that, OK, there's a new CRD was created, so I should create a new volume. So the manager inside Longhorn Manager are going to create the Longhorn engine and the replica, and then they will form a Longhorn volume. So if there are more requests to create more volumes, we just simply follow the same flow. And another important part of Longhorn is the Longhorn UI. Longhorn UI is talking to the Longhorn Manager also through the Longhorn API, and is acting as the complement of the Kubernetes. Because normally the Kubernetes CSR plugin gives you the ability to attach, create, delete, attach, detach, mount, unmount the volume. And there are snapshot functions there, but they're still in the alpha. But all other functions provided by Longhorn are implemented through the Longhorn UI, like snapshot, backup, node management, disk management, and all of that. And we are also planning to have a Longhorn CLI very soon before we release the GA. So let's talk about a little bit about our currently Longhorn community. Since Longhorn is a totally open source project, we really encourage community's engagement. Currently, Longhorn has over 900 GitHub stars, and we hold a monthly community meeting at 9 a.m. Pacific time on the second Friday morning, which I checked, which is no other CNCF meeting held at the time. And we have over 300 users, which combine the two Slack channels. One is in the CNCF channel, which is we created after we donated Longhorn to the CNCF. Another one is the old one we resigned in the Rancher user and the Longhorn storage, and we are migrating from that. So the community contribution are welcome, and there are different formats of contribution. You can help to fix the docs. You can help to find some issues and file feedbacks or feature requests. All this are really valuable to us. Many of the features I mentioned before, like say when users see the Longhorn volume name inside Longhorn UI, they also want to see the workload. That in fact is the feedback from users, because if we only give them the PVC plus UID, they don't really know which workload associated with that. So that is the direct result from the user feedback. So we do have a large target in 2020. The first thing is we want to reach 1.0 GA, and including features like volume resizing, performance metrics, QoS, etc. The volume resizing is just many people mention that volume resizing is probably the biggest issue that stops them from using Longhorn more extensively. So we like to address these sooner than later. And we also want to increase the community by 10 times. Given us our base is still pretty small, I think it's probably doable. And we want to reach the incubator level in the CNCF, and that requires the engagement into the community. So we are really working on that. So that's all for my session. Any questions? Oh, thank you. Yes. In fact, on both cases, it's OK. So for Longhorn, you can install Longhorn using Helm chart. That code is in the Longhorn/Longhorn repo. And in fact, the Rancher app catalog is in fact Helm chart too. And also, the one you see that I starting WordPress using Rancher app catalog, that's in fact also Helm chart. The only key point that if you want to use Longhorn for your storage is just set your storage class to Longhorn or other storage class you create customizedly, but with the Longhorn as your provisioner. That's the only key point. Oh, yes? Sorry.
Do you have a feeling for the performance of a DD input or a DD output on a raw node and then running through the Longhorn stack? What's the stack that you say you run it through Longhorn stack?
We don't really have an official performance number right now. I can say I'm pretty confident Longhorn's performance should be at par or better than Ceph. Of course, in fact, this one is coming from some users, their benchmark, and they found that. So in fact, the most focus we have right now is on developing features and stabilize it. And of course, we'll take some time to look at the performance before we reach GA, but it's not really at our priority at this moment. We want to have more people using it because the one thing about storage is the stability is really important, and we never want to lose anybody's data. So we want to make sure that will never happen before we can really start optimize that. Building on that shouldn't be a really big problem because we don't really haven't looked into that. There should be a lot of low-hanging fruits there. Yes? No, so Longhorn is a block device, so block device supporter, so we only support the read-write once. And the reason is if you change the block device content without file system knowing, the file system will basically panic. So we only support the read-write once. Sorry, I don't get the question. Yeah, so the replica with each replica is identical. By default, we have 3 of them, but they contain the same data, and they don't directly provide access to the data. User have to go through the controller, which is going always on the same node as a pod, and provide the front end for accessing to the data. Yeah. Yes, each volume has one engine. Okay, in fact, that's interesting because we used to put engine and replica each in a separate pod, and their users with powerful machines quickly hit the limitation of 110 pods per Kubernetes node. So in the 2 releases before, in the 6.0 release, we decide to put the engine as a process instead of pod into Kubernetes. So now the engines are running the process in called Instance Manager pod, and we can have multiple engines in there. Yes? So I don't really get the question because the daemon set itself normally, because there's a daemon set, right? So normally they use the local storage. They know where the node at. They're not really migrate between the node. So if you want to use Longhorn for daemon set, you will probably going to have one volume for daemon set, but the daemon set doesn't really have volume claim template. Yeah, you should use a stateful set for if you want to scale your stateful applications. Yeah, so if the network partition happens, the source of truth is in the controller. If controller thinks this replica is dead, it's dead. If controller thinks this replica is healthy, it's healthy. So all the consistencies are controlled by the controller, and the controller only runs on one node as one process. That's okay. So when network partition happens, the pod, because as I mentioned before, the controller always resides in the same node as the pod. So pod will always have access to the controller. And if that only one node got isolated, if you have a replica running on the local node, the controller will still able to access to that replica and think that is only one is healthy. If that node doesn't really have any replica, controller will error out, and you will see that it's basically like, say, that node down case, ideally the workload should be migrated to the other pod in order to access any storage. Yes? No, because it's read-write once, but it can be used by the multiple pod on the same node. No, because it's, at least now, yeah. So it's a block device, so we cannot really modify the block device without the file system knowing. Yeah.
What kind of control do you have with replacement? So, for example, you support the Kubernetes data zone for nodes, that kind of thing? Or how do we say we want the first replica over here and the second replica over here?
Yeah, so it's up to Longhorn to decide where to place the replica. We have a scheduler to basically look at what the node you tagged, what the disk you have to tag, and try to first match that, and then try to fit that. Okay, so you want to 20G or 100G volume, so the replica will be 100G, and let's see which disk can fit that. And we try to put that in on the different node as possible. So basically, the Longhorn is doing the scheduling for you. Yeah, so I don't know much about the beta zone. We can discuss offline. I can check it. Okay. Yeah.
Is Longhorn being run in production anywhere?
Not really, because just before last Friday, Longhorn is still in alpha, and now last Friday we released the first beta release, and that's probably the reason why you haven't heard about it much. But we are expecting. We have a lot of interest, and there are many users. I think it's not really on the very large-scale production, but there are users saying that they are running Longhorn in production, probably in their small website or home environment, those kind of cases. And we will expecting more to come.
Are you guys using Longhorn yourself?
Yes. Yeah, we internal framework is using Longhorn to store our data on our daily tasks.
How is that going?
So far, so good. Yes?
What's the resource requirement?
The resource requirement will definitely recommend that you have at least 2 vCPUs, better with 4 vCPUs. But this basically depends on how many volumes you want to create. So we will have a guideline before the GA, and that's also corresponding to what's the CPU utilization, those kind of stuff. Yeah, and the performance. We'll definitely get a guideline before the GA and give you some ideas. Yes? Sorry, I didn't hear the last part. Yeah, so Longhorn itself is running on the user space. Okay, that's in fact a very interesting question. We have probably spent a year trying to figure out what's the best way to do it. And in the end, we choose to use TGT as the backend, and the Longhorn, in fact, does connect to the TGT and expose an iSCSI target. And then Longhorn will call the open iSCSI running on the host initiator to connect to that target and expose the block device. Previously, we have tried NBD, and we have tried the Fuse with mounted, and also, in fact, we have tried the TCMU, which is the user space Linux in-kernel iSCSI target, and I have contributed a bunch of patches to make it performance improvement. But in the end, we think is we don't really. It's hard for us to require users to have to run certain version of Linux in order to get Longhorn running. So we make a compromise and choose the iSCSI. We choose the TGT and the iSCSI as the final solution. Yes. Yeah, so currently now we don't have extension yet, and we have abstraction on the different levels. For example, we are open to accept new backup store drivers other than S3 and NFS. And other than that, we don't really have other extension planned at this moment. But yeah, since we are open source, everything is subject to change. Yes? Not right now. Now all the data plane traffic goes through the Oviatt networking. We are investigating a way to, if you want, you can have a dedicated storage networking and go through that traffic. But that is not hasn't been implemented yet.
So beta projects kind of have two different ways. You know, like Terraform, they're still in beta, but they try really, really hard not to break things.
Yeah. We are really trying not to break things since alpha. There are many users upgrading from 0.3 to 0.4, 0.5, 0.6, 0.7, and they're still upgrading. So I don't believe many objects support upgrading in the alpha stage, but we are really trying to put a lot of effort trying to make sure that users have a smooth transition, because we know that the early adopter is really important to us. And we want to make sure that we got the feedback. We make sure we fix every problem we can think. So that is why we want to make this user experience great, and that's why we support upgrade. Yes?
I just want to confirm that the way the Longhorn engine works, that we can still use cloud security policies to lock down.
Yes, yeah. So, but in fact, that is a little bit. We need to look into details what policy you want to set. There are users using policy security policies, but I didn't record the details. There's one issue on that, and we have solved it. And if you have more information, we'd like to hear more feedbacks. All right, so thank you.